So I got a great question today about lifts, alignments, and steering systems. So I'm going to make a couple different videos on this topic, and this first video is going to be about how the suspension lift impacts your alignment, and once you do a suspension lift, what's the best way to get it aligned. So the suspension lift on a Nissan Xterra typically revolves around the upper control arms right here. Now, I'm going to simulate doing a suspension lift by just putting a high lift jack on the side of my vehicle, and I'm going to raise the vehicle by the frame. And I want to show you how the suspension flexes and what is actually happening to your steering components as you do a lift. So that's about 3 clicks on the high lift jack, which is about an extra inch or so of actual lift. You can see that the gap at the bump stop has narrowed quite a bit. It's getting close to contact there. You can see that the angle of this tie rod has gotten much steeper. It's sloped downwards a lot more, and the angle of this control arm is also sloped downwards more, so that's at a more extreme angle. So now you understand that you need to get in alignment after you do a lift. It's just a fact of the geometry of the suspension. So an overview of alignment angles, you have 3 main angles that are typically adjusted. The first one is the toe in, and this is basically how straight are your tires pointing forward, and that is controlled by this tie rod adjuster. This is basically a turnbuckle where it has regular threads on one end, reverse threads on the other, and you can twist the turnbuckle or the tie rod adjuster, and it will make this overall linkage either shorter or longer, which in turn will point the tip of this tire either further outboard away from the vehicle or bring it further inwards towards the center of the vehicle. So the second angle that we need to adjust is camber, and this is the measurement of how straight vertical your tire is up and down. So the easiest way to explain this is simply, what if you just took a normal level and you just put it on your tire and said, okay, is the top edge leaning inwards or outwards relative to the bottom? And the third and final angle that we typically adjust is going to be caster, and this one is a little bit more abstract. This is basically the steering axis between the upper ball joint and the lower ball joint. Is it vertically straight up and down, or is it tilted backward some? So all that basic information is pretty great, but caster and camber are the most difficult ones to align and get done properly, and here's why. With toe in, it's very easy to adjust because you just adjust this turnbuckle, and that will independently set your toe in angle without interfering with your camber or caster settings. Camber and caster on an upper control arm type suspension system are interrelated. They are controlled by the 2 mounts on the upper control arm. So if I go above the tire and look down on that upper control arm, you can see there's 2 mounts. There's one mount here and one mount right here. Now camber and caster are both adjusted by adjusting the position of each of these mounts relative to each other. Now if you look at the bolted joints on these mounts, they're not just a straight concentric hole. In the frame here is actually a slot, and the bolt is actually what they call a cam washer or a cam bolt system. So we have an oval washer that is fixed to that bolt, and by rotating the bolt a certain way, the eccentric or oval washer rides on this surface, and it can either slide the pivot point further inwards towards the back of the frame or outwards away from the frame.
So on the screen right now are 2 different sets of alignment specs. One is the commonly passed around specs on the internet for a lifted vehicle, and the other one is the stock alignment specs. So the lifted alignment calls out a camber angle of 0 degrees, so you want your tires vertical. The caster is specified to be maximum caster on the passenger side while maintaining 0 camber, and adjust the driver's side caster to be slightly less while maintaining 0 camber. That's a little convoluted. The toe in is 0.33 degrees or 0.16 inches of total toe in. So compare that to the stock alignment. Stock settings of camber is 0.1 to 1.1. That's positive camber, so the factory settings allow the top edge of the tire to be tilted outward some. The caster angle is 1.67 to 2.67 degrees, and they actually don't call out any type of caster split or a difference from left to right or passenger to driver. And the toe in is 0.33 degrees or 0.16 inches of total toe in. So what's the real difference here? Toe in is the same on both of these sets of specs. The only real difference is that on the lifted alignment, we're specifying 0 camber, and we're willing to sacrifice a little bit of caster to make sure that we keep our tires perfectly vertical. It's really just a modified version of the factory specs, and there's not a whole lot different. So how do you actually get a tire shop to implement these specs properly? It's going to be difficult because a lot of alignment techs just rely on a laser alignment rack to tell them which bolt to spin until they hit the factory specification. My recommendation is to first see if you can get a lifetime alignment deal at a local tire shop like Firestone. That way you're not paying for multiple alignments over and over. And with some basic hand tools and a little ingenuity at home, you can do the camber and caster measurements and get a pretty good approximation to these specifications, and then you can have the tire shop just adjust toe-in only.
So the root of everybody's question is going to be, I just installed my upper control arms. Now how the heck do I get an alignment? So based off of the alignment specs, what I typically do is I say go ahead and adjust your control arms when you install them to maximum caster. So to get maximum caster, you want the one towards the front of the vehicle. Again, these mounts are in slots. So you want to adjust the bolt so it is farther away from the frame outboard of the vehicle. The mount on the back, you want to adjust it so the rear mount is further inboard, closer to the frame of the vehicle. When you adjust your upper control arm mounts in that way, what it actually does is it takes your upper ball joint position and it puts it in the rearward most position, meaning that the upper ball joint is further back on the vehicle and it's farther back on the vehicle relative to the lower ball joint. So that gives you your maximum possible caster. So that's a good starting point for getting your alignment. So now that you have the maximum caster starting point dialed in, you can come up with a pretty good estimate for your overall camber. Like I showed earlier, you can take a level and just put it top to bottom to figure out if your upper edge of the tire is tilting inwards or outward relative to the bottom edge of the tire. If you want more precise measurements, you can do like I did. I made a camber gauge out of some 3/4 inch square tubing. Take it off the tire and show you. But it basically looks like a T, and it has some long 3.5 or 4 inch bolts that stick out of it. Those serve as a standoff, so you can align this on your actual rim. It lets this vertical post stand off of the hub so you don't interfere with that. I just use a small level. Make sure that the T is level to the ground. So I'm on a concrete garage floor. And then I have a digital angle finder here. So at least this tells me the angle of my rim, which this says 89.75 and relative to 90. So I'm basically 0.25 degrees of negative camber here. So that's pretty close to 0. That's in the ballpark. I'll take 1/4 degree. So based on your camber reading, let's say that you need to bring the top edge of your tire inboard, closer to the inside of the vehicle. So based off of that maximum caster position, the only mount I can adjust is the front upper control arm mount. Now the maximum caster position has this mount farther off of the frame, so I need to adjust it so it goes further inwards towards the inside of the vehicle, just enough so that I have 0 camber. Once I have about 0 camber by adjusting that bolt in, I'm done because I have now maximized Casper while maintaining 0 camber. The only thing left is the toe-in adjustment. My recommendation is to eyeball your own alignment for camber and caster based off of this maximum caster starting position, and then let a tire shop do the toe-in. They can get that much more precise, and I drop it off for an alignment and I just say toe-in only. And then I check the specs when they do the printout at the end, and I can compare my hand measurements to the actual shop measurements.
Hunter Engineering, which makes the laser alignment racks, had a great PowerPoint presentation that was searchable through Google. For positive camber change, you need to move both control arm mounts outward together. For a negative camber change, both control arm mounts need to go inward together. To get positive caster change, you need to increase the offset between the two mounts, with your front mount moving outboard. For a negative caster change, you need to increase the offset between the two mounts in the opposite direction. For positive camber and caster, your front mount needs to be moved further away from the vehicle outward. For a negative camber and caster change, you need to adjust your front mount further inboard. For positive camber and negative caster, you need to adjust your rearmost mount outward. For negative camber and positive caster, you need to adjust your rearmost mount inward.